Hey everyone, welcome back to The Explainer. Today, we're unpacking a really fascinating conversation between tech titans Jensen Huang and Elon Musk, all about the future of global AI infrastructure. We are going to take a journey that starts with microscopic computer chips and ends with a massive post-currency future for humanity. If you want to know exactly where this next big tech leap is taking us, you are in the right place.
So here is our roadmap for today. We'll be hitting 5 key areas: the computing shift, building AI factories, moving AI into space, digital twins and robotics, and finally, a post-currency future. And as you'll see, each logical step here builds directly on the one before it.
All right, let's jump right into Section 1, the computing shift, and the reality that Moore's Law has effectively run its course.
We are right in the middle of a massive paradigm shift. Think about it like this. In the past, computing was mostly retrieval-based. Someone wrote an article or saved a file, and when you interacted with the system, the computer just went and fetched that preconceived information. But today, we're rapidly moving into generative computing. Software is now literally generating unique, real-time content based on your specific context and prompts. So, we're transitioning from a world that just fetches pre-made files to an intelligent one that generates completely dynamic, unique answers on the fly.
And the sheer speed of this transition is staggering. Just look at this. 6 years ago, standard general-purpose CPUs made up 90% of the world's top 500 supercomputers. Today, they count for less than 15%. Jensen Huang points out that we've rapidly pivoted from general-purpose computing to accelerated computing. This isn't just a simple software upgrade. We're talking about a complete replacement of the digital world's underlying plumbing to support all this new generative demand.
Which brings us to Section 2, building global AI factories to actually power this new generative era. Because every single generative computation is unique and happens in real time, we just can't rely on traditional data centers anymore. We need entirely new, massive physical infrastructures. And the scale we're talking about is mind-blowing, 500 megawatts. That is the power target for the newly announced XAI supercomputer project in Saudi Arabia, which is being built in partnership with Nvidia. To put that into perspective, that is an astronomical leap in energy infrastructure. We're literally moving away from standard data centers into what the sources are calling global AI factories.
But as we scale up these massive factories, Earth quickly runs out of room, and more importantly, energy. That leads us to Section 3, moving AI into space, which leaders propose as the ultimate scaling solution.
Well, the math gets pretty wild here. Step 1 is where we are right now, hundreds of megawatts for single AI data center projects. Step 2 scales up into gigawatts. For some context there, the entire US power grid averages about 460 gigawatts of usage a year. But to reach the ultimate capabilities of AI, leaders project we're going to soon demand terawatts of compute power. At that level, it becomes physically impossible to build power plants of that scale on Earth. When AI demands cross from gigawatts into terawatts, the argument is that we simply have to take our compute to the stars.
So why space? Well, look at these brilliant natural efficiencies. Out in space, you have continuous solar energy. I mean, there's no nighttime. Because the sun is always shining, you completely eliminate the need to launch heavy, expensive batteries. The solar panels themselves actually become cheaper because they don't need all that heavy glass framing to survive earthly weather. And finally, you get effortless radiative cooling right in the cold vacuum of space. According to Elon Musk, space computing might actually become the absolute cheapest method for AI in just 4 or 5 years. No way, right?
Actually, to put that cooling thing into perspective, check out our current earthly limitations. Right now, in a typical 2-ton supercomputer rack down here on Earth, 1.95 tons of that weight is dedicated entirely to cooling. Just imagine that for a second. Almost the entire bulk and weight of our current hardware is literally just trying to stop the chips from melting. It's a massive engineering headache that beautifully vanishes the moment you move operations into space.
Okay, let's bring those massive cosmic computations back down to Earth. Welcome to Section 4, Digital Twins and Robotics, where we see how this software leaps out of the server rack and into our physical reality.
So how do you teach a robot to walk without it falling over and breaking a million times in the real world? Well, Nvidia solves this with something they call the Omniverse. It's a physically based digital environment, a digital twin of reality, that strictly obeys the real laws of physics like gravity and fluid dynamics. So long before a humanoid robot takes its very first physical step, it is already trained and learned to be a good robot safely inside this perfect digital playground.
And once those robots are ready for actual physical production, we're going to see a familiar economic playbook. You know how Tesla disrupted the electric vehicle market by dropping battery costs from over $1,000 per kilowatt hour down to sub-100? Well, Elon Musk plans to apply that exact same first-order scaling to humanoid robotics. The ultimate goal here is to completely collapse the cost of the underlying physical components, things like actuators, servo rotors, and motors.
Now, it's not just about future humanoid robots, right? AI is already acting as a superpowered assistant in the real world today. For example, instead of replacing radiologists, hiring for radiologists is actually up. Why? Because AI makes studying images so productive that doctors can see more patients and diagnose way better. Plus, using accelerated AI models, researchers have already developed microscopic sponges with 33-nanometer pores that literally pull water out of dry air. And there are nanorobots capable of doing gene editing to fight sickle cell disease. AI is enabling some truly incredible breakthroughs right now.
And finally, we reach the end game of this unprecedented infrastructure boom, Section 5, a post-currency future, looking at the massive, long-term societal outcomes these tech titans are predicting.
Musk makes an extraordinary claim here. My prediction is that work will be optional. AI and humanoid robots will actually eliminate poverty. The stated roadmap for these massive AI factories and billions of robots is an era of absolute, ultimate productivity. If we have infinite digital intelligence and tireless robotic labor, the leaders argue we can reach a state of post-scarcity, where the fundamental needs of every single human are met without forced labor.
Musk uses this great metaphor to illustrate what that actually looks like. He says work becomes like growing your own vegetables. You can easily just go to the store and get them, but you might choose to grow them in your backyard because the act of doing it brings you joy. Using this analogy, he explains that human effort will shift entirely away from mandatory survival labor and instead move into passionate hobbies and creative pursuits.
And if you pull that thread all the way to its logical conclusion, you arrive at this quote, "I think at some point, currency becomes irrelevant." It's a huge concept to wrap our heads around for sure, but the logic flows directly from our earlier points. If limitless solar energy is harvested in space, and robotic labor can manufacture goods infinitely, the underlying cost of essentially everything plummets to near zero. So the leaders suggest that traditional money, which is basically a mechanism to ration scarce resources, might eventually vanish entirely.
Now, to balance out these massive, kind of sci-fi predictions, the panel reminds us of the historical realities of technology. While we definitely tend to fixate on the short-term disruption that new tech brings, history proves that long-term, every general-purpose technology has ultimately created net new positive value pools. It makes us more productive, gives us the freedom to pursue a massive backlog of human ideas, and ultimately creates a net positive for humanity's workforce.
So, as we wrap up this deep dive into the infrastructure of tomorrow, I'll leave you with this wildly fascinating thought to ponder. If AI factories and space-based computing truly make work optional and currency completely irrelevant, what will drive humanity next? What's going to be our purpose? Thank you so much for joining me on this explainer. I really hope these concepts helped illuminate this incredibly fast-moving topic for you. Until next time, stay curious and keep learning.